task was to create an advanced energy vehicle, or AEV, that ran on a monorail system that was propeller driven for the Rebel Alliance in order for them to ship R2-D2 units from one place to another using this monorail, which pulled the wagon on which the units were hauled. So our goal was to create a vehicle that accomplished this task while using the least amount of energy per mass of the vehicle. The planet on which this situation took place has low access to energy, and so they need to be as efficient as possible in order to accomplish their goals.
After convening as a group and considering the pros and cons of each individual design, the team decided to create an AEV vehicle with two propellers facing opposite directions but in line with the body of the AEV. This body would consist of a plastic frame, the AEV controller, and a battery pack on each sides of the frame. Now, both the body and the propellers would be encased inside of a plastic tube in order to better direct airflow. And finally, the 2510 propellers would be used over the 3030 propellers because only they would be able to fit inside of the plastic tube.
So throughout the whole AEV project, we have been testing different components to determine the most efficient AEV design. And one of the components that we tested was what type of propeller to use in our design, because we were given large propellers and small propellers. So in the initial design with the plastic tube, we had to use small propellers because the large propellers did not fit inside the plastic tube. But through testing, we found that the large propellers were actually more efficient than the small propellers, and decided that the efficiency of the large propellers was more important than having the plastic tube, so we decided to use large propellers in our final design. In addition, we tested two different types of braking mechanisms. One involved a servo motor where we rotated the servo arm to touch one of the wheels, so we used friction to brake the AEV. And the second type of method that we used was what we call air braking, which is basically reversing the direction of the motors and to propel the AEV in the opposite direction. And we found that the servo motor or the servo method used less total energy than the air braking method, so we decided to use that in our final design.
A big portion of the work for preserving the energy had to be done after the actual mechanical AEV has been built. The work had to be done for finding the best programming approaches to enable the components to perform for their full efficiency. The team tested two different programming approaches for driving the AEV. One of them was giving it consistent power to go throughout the track, and the other one was to burst the energy at the beginning and let it coast to its destination. The team found that the second approach, the bursting energy, used around half of the power that the consistent energy approach used. Also, the team was able to reduce the energy that the servo braking mechanism was using by finding the precise angle when the servo hits the wheel. Otherwise, if the servo tries to rotate the arm too far, it gets stuck and uses far more energy.
So through working as a team on the AEV project, we learned a lot about planning ahead and how planning ahead for labs, large assignments, and other parts of the project really helped us when we ran into unexpected issues such as hardware malfunctions. We also learned about the importance of version control in both our documents and our code, and how version controlling documents and code allowed us to quickly go back and look over how things changed over versions, and allowed us to revert whenever there was a formatting issue or something came up that was unexpected with our documents or code. Also learned to expect inconsistencies and how planning ahead really helped us avoid those inconsistencies. To overcome those inconsistencies, and when those inconsistencies arose, we learned to really have to work in a calm, organized format to overcome those inconsistencies and still maintain on schedule for what we wanted to accomplish throughout the project. Finally, we learned to really make sure that you test things in a smaller scale before you jump to the larger scale. This was applied throughout the project by testing on the desk, testing out our code to make sure there were no bugs in the code on the desk before bringing it up to the track where damage could have been caused to the vehicle.